The second class that we are going to look is IP network. So just like the IP address, here we are going to create an IP network object. There's many ways you can create. The one way that I've specified the network and the mask is in the CIDR notation. Here I've specified using the network mask. So let's just run them. Okay, and both of my objects are created. So in the similar way, let's just print out. So if you can see, it's just my uh, object, and then the type of object is obviously a class. So we'll see what are all the methods that is available on an IP network object. We can print the object with the net mask, with the IP address and the network mask format. We can print it with the prefix length, which is CIDR notation. We can print it with the host mask. uh, this is also known as reverse mask, which is used in OSPF network statements and all of those things. We can only print the subnet mask. We can only print the host mask, and we can print only the prefix length, which is 24 here. Now we can also print or show only the network part of the address, excluding the mask values, either in CRDR or the net mask notation. Next, we can see what are all the number of addresses that is available within an subnet. So you can see this includes your network address and the broadcast address, everything. So it's basically um, 2 to the power of 8, right? That many IP addresses that is available. And next, we are going to see all the hosts that is available within the subnet. So the way we do it is, if we the method that we are going to call is dot hosts. But as you can see, if we just do that, what we are going to what the IP address is going to return to us is a generator object, and we have to iterate it so that we can get the individual IP address. So if we iterate it, this is what we are going to see. We are going to see, let me reduce the window size. You can see 10.10.10.1, 10.2, 10.3, things like that. But if we just need the 10.10.10.1 part, the way we are going to do is we are going to only print the string part of the when we iterate, we are going to print only the string part. And now we can see we are only seeing dot 1, dot 2, dot 3 up till 254. So obviously this is a list, and you can iterate over this again if you want to, let's say, check the reachability of each IP address or something like that, for example. So next, just like the IP address, we can perform some operations on the IP network. We'll start by seeing if there is um, if a given subnet is within another subnet, or means to say is a subset or is a subnet of another subnet. So basically what I'm seeing here is I'm going to say if, let me see. Okay, I know what's wrong. Give me 1 minute. So we are going to see if now we are going to see if 192.168.1.1 is within 10.10.10.0/24. Obviously it is not. And then we can see if 192.168.1.1 is within 192.168.1.0/24, which is true. So basically you can check if a given IP address is within a subnet or outside the subnet. Next, we can see if the two network overlaps one another. So basically I've created two network objects. The first one is 192.0.2.0/24, and another one is 3.28 3.0/28. And and the way I check is n1 dot overlap of n2. So the argument that I'm passing to the overlaps method is n2. And if I see here, I should say false. That means 3.0/28 is not a part of 2.0. So similarly, I can check if one network is a supernet of I can see what is my supernet. That is to say, uh, let's say my given subnet is 192.168.77.0/26, and I want to know which is the supernet, which is the /23, which contains my network /26, and the answer is 192.168.76.0/23. And similarly, I can check what is the supernet of my subnet with a prefix length difference of 2. That means my prefix is 26. The difference is 26 minus 2, which is 24. So tell me the 24/24 which contains my subnet, the subnet of interest. So see here, it gives me the /24 which has the given /26. And similar way I can see, if a given network is a subnet of another network. So here I'm checking if n2, that is 192.0.2.0/28, is a subnet of 2.0/24, and it is not. Is n1, because this /24 is much bigger than the /28. So obviously I'm going to see a false. Again, supernet of true. So basically I'm saying this 24 is a supernet of this 28. And next I'm going to list all the subnets of a CIDR. For example, I have a 10.10.10.0/24. I want to see all the /26 which is present in that /24. So let me start with, I think we can, uh, again, what we are doing is just like the hosts that we generated, we are going to generate the subnets. If I print that, I can see /25 and /25. So if I just pick the string part of the iterator, I'm going to see the /25s. Um, in the similar way, I can print all the subnets which has a prefix length difference of 2. So if my given subnet is /24, I can see all the /26. So if I do it here, this is all my 26. And I can also specify what should be the resultant uh, subnets, what should be the net mask of the resultant subnets. For example, if I need to print all the /30s, I can directly mention all the /30s, and then I can get all the /30s which is present within the /24. So the last one which we are going to see is sometimes the argument that we pass, right? For example, if you see here, I'm creating an IP address of object, but this is not in this example. This is not 192.168.0.0. I'm I'm passing an argument 192.168.0.1/28. This is not a strict definition of a network, because the host bit is basically set. So it should have been dot zero, but my argument says it's dot one. So if we were to run this as is, I would see that this the whatever the argument that I've passed has the host bit set. Just to overcome this, what we can do is we can pass an additional argument strict is equal to pass, which is going to remove all the host bits set, and then we are going to get the IP address object returned.